All right, welcome everybody to another Pygame lesson. We are continuing on with our kind of SpongeBob SquarePants game that we have been working with. And let's just kind of take a look at what we've made so far. So I'll run this Python file. And we had a SpongeBob kind of sprite, or it was kind of static, so it's not animated, but we could move this around using the WASD keys. And then we also coded the background and the starfish and the pineapple to kind of have some different movement patterns going around the screen. So a couple of things that we talked about last time was that, it'd be nice if maybe SpongeBob couldn't just go off the screen. And that sort of thing requires kind of some collision detection. So as we've coded things so far, we have made things as these kind of surfaces. So we've imported an image, and that Pygame turned that into what it calls a surface. And there are some limitations to those surfaces, which are kind of like what we're experiencing now. If we want to code like the starfish hitting SpongeBob, or if we wanted to make sure that SpongeBob doesn't go off the screen, the math involved there gets a little bit tricky. Because when we had SpongeBob, for example, we were only tracking a single point on this kind of rectangle. There is a rectangle on the surface, and we could only really track the top left. So as we're moving SpongeBob around, we're still only really keeping track of this top left coordinate, which, since there is kind of some invisible background here, it's not even like touching Patrick or SpongeBob right now. So doing all of the math based off that one point gets a little tricky. And we saw that with sometimes the starfish. We were kind of looking at adding 50 pixels, which was the width of the starfish, or maybe subtracting it. So we're going to, in this lesson, what we're going to do is we're going to make a change to how we're storing our surfaces to make the collisions possible. But by the end, we're not actually going to see anything different. The ending program, when we run it, is going to look almost the same as this. But it'll kind of let us handle collisions later, which is a really big part of any game. Okay, so let's close this, and we'll take a look at how we update our code. So if we look at, I'll just close this terminal window out so we can see more of the code. If we look at how we define things, let's look at this SpongeBob one, for example. So we had the SpongeBob variable, which was equal to us loading in the image. So pygame.image.load. So remember, when we see a method like this says it's in the Pygame library. Inside of that library, there's a whole image section. Under the image section, there's a loading function. So we can pass that in a file name, and then there was this extra convert alpha thing that kind of optimized it for us. We've just been doing that for everything, just to make sure that we're not being inefficient. Then we also had these two things here, sponge X and sponge Y, and that tracked our coordinates for us. So with that, that's one of the things that is going to change a little bit with our rectangles that we're going to make. When we let Pygame keep track of these things for us, we don't need these variables to track it anymore, because we're going to be able to track it differently. Let me show you an image of what I'm talking about here. So when we let Pygame keep track of the rectangle for us, rather than just dealing with the image surface where we only had access to this top left, once we make a Pygame rectangle that goes on top of the image, we can then track that rectangle and check its kind of left coordinate property, which is the whole left side. We can check like the bottom left, we could check the bottom right, we could check the right, the top right, or the center. Okay, so this is really useful in a lot of different instances. For example, if we wanted to make sure SpongeBob and Patrick couldn't go off the top of the screen, then we would use probably this top coordinate, and make sure that the top can't be, less than 0 or something like that. And similarly with the bottom, if we want to make sure SpongeBob couldn't go off the screen at the bottom of the screen, rather than like starting up here with this coordinate and then doing some math that includes, how tall is that image that we're dealing with, rather than doing that, we can just say, okay, make sure that the bottom of that rectangle isn't bigger than the height of the screen. And so by just changing the reference, the easiest reference that we want to use for this rectangle makes a lot of the different things you might want to do in the game a lot easier. So we are going back and changing kind of how we've done things. This is just throwing on another layer of using more of the game engine, but it does make it a lot easier because the game engine has so many different things that will help us. Okay, so we're going to go back into the code here. So we'll kind of go through and we'll end up removing the variables we have that are tracking the coordinates because Pygame will do that by itself. But we're also going to have to, after we make an image, something like this, we're going to have to get a rectangle on top of that. Okay, so let's start with that first method here. So we'll get into the code. The first thing here is that we're going to use it's called the getRect method. So we are going to say, if we have a SpongeBob variable, we're going to call this maybe the SpongeBob rect variable. Okay, so SpongeBob is the image itself, but then we also put a Pygame rectangle also on the image, and that's what is going to handle the collisions. Okay, so what we do is we call the original image layer, which is SpongeBob, that is the image, but then we use this getRect method here. So getRect, and then you don't have to put any arguments in here, but it will be useful in just a second. So what we'll do is let's leave that blank for now. And I'm going to just delete some of these sponge x coordinates here. So I'm going to delete the sponge x and sponge y. And that's going to break some things later on in the code, right? Because there are some things we're going to need to update here, for example, where sponge x and sponge y are mentioned there. And they're also mentioned in the different spots there. So maybe just because there's a lot of updating to do there, let's just, if we don't put any arguments inside of this getRect, what it does is it just puts it at the top left of the screen, which is the same thing as making sponge x and sponge y equal to 0. It just puts it at the top left. So I'm just going to run this for example here to see if nothing breaks. So nothing is broken here, but now what's happening is that even though I can still move everything around, there is a rectangle around SpongeBob. Now the coordinates are a little bit tricky because technically there is a layer which is just the image, but then there's this invisible rectangle on the top. So there might be a little bit of a disconnection between that invisible rectangle and the image right now, just because I'm kind of halfway through editing the code. But that's essentially what's going on here, is that there's going to be one image layer and then one invisible rectangle, and the rectangle is attached to it, and we can do any math or collisions based off of that invisible rectangle. So let's close that out, and we're going to make the different edits here now. So I'm just going to do everything SpongeBob related first, and we'll kind of see how that works, and then we'll go through and do the other two images that we loaded in, which were the pineapple and the starfish. So I'm going to delete sponge x and sponge y. Okay, to access, for example, I'll just write a little comment here. To access SpongeBob rect coordinates, we do it kind of similarly to how they have this kind of pygame.image. There's a period in between. We can use, for example, SpongeBob rect, and then we do a period, and then we can call any of these different positions. So what I'm going to use kind of at the beginning is I'm going to say center. So SpongeBob.center, we could do something like this. And this will, I just want to make sure I spelled center right. This will access the center coordinate for SpongeBob. Okay. So I'm going to use that right away, actually. And I'm going to put in, earlier in the video, I kind of approximately placed SpongeBob in the middle. But this is actually going to be a lot easier by using this rectangle. So one of the things you can put inside when you make your rectangle is that you can say the center is equal to, and I have my variables here for screen width, which is left to right length, and screen height, which is top to bottom length. So I'm going to say I want the center of this SpongeBob rectangle to be at the screen width, but divided by 2. So I do a /2 in there. And then the height, I want it to be the screen height divided by 2 as well. So this is going to put the center of SpongeBob right at the center of the screen. So this one line of code makes it so I can put SpongeBob right in the center of the screen at the beginning, and I don't have to do any extra math to work out, how tall was SpongeBob, how wide was SpongeBob, and I don't have to do any of that extra geometry. This just kind of takes care of it on its own. So this is going to put SpongeBob at the center of the screen. I could access other versions of those coordinates later using SpongeBob rect dot top left or dot bottom right, that sort of thing. But let's, and everything else will move relatively here. So let's get to the next part where we have sponge X and sponge Y. That's what we're looking for now. We're kind of on a hunt for those things. So here is kind of the first one that I see here. It's at line 48 here, where we had our screen blip, where we were drawing the image to the screen. So now that's going to get a little bit changed. We have to now blit those things using the rectangle coordinates. So it's actually going to be a little bit more simple. Rather than passing it this kind of X and Y coordinate at the end, we can just say, draw SpongeBob at the screen where its rectangle is. So we're just going to say SpongeBob rect. That was the variable name for the rectangle. So this now, rather than saying put SpongeBob on the screen at this coordinate, it just says put SpongeBob on the screen where its rectangle is. And as we move around the rectangle with the WASD keys, this will kind of update itself. So this is just a little bit more simple. Again, we're kind of letting Pygame take care of some of these things for us. Now let's look for the next. I'm just going to do a Control F here. I'm going to look for sponge X just to make sure I don't miss anything. This will kind of find everything, and it'll just it'll highlight where I need to make changes. So if we look down, there's only maybe 2 more of them here, and then there's some sponge Ys down here. So this is where the key pressing was happening. So rather than using sponge X, because this variable doesn't exist anymore, we want to access the rectangle, right? So rather than this kind of sponge X is equal to sponge X minus the speed, how many pixels you want it to move when you move left, right, up, or down, we're going to access the X coordinate of the SpongeBob rectangle. So this gets done like this, SpongeBob rect. So again, that's the variable name for the rectangle. And if we want the X coordinate, it's just .x. So we don't have to reference, we're not going to reference top left, bottom left, or any of these 9 positions. We can just say, what's its X coordinate, what's its Y coordinate. It'll probably, I think Pygame will, by default, measure its top left coordinate. But we don't really need to know that detail because, again, we're letting Pygame handle that for us. So I just need to change that in both places. So we want its X coordinate to equal its current X coordinate, but minus the sponge speed, which I think we set to 5 earlier. So this is going to move it left. So we're just going to make the exact same change here, sponge X and sponge X. To move right, it was increasing by the sponge speed. So we don't need to change any of the logic. We just need to change the reference here. I think I spelled something wrong. SpongeBob. There. Now it's highlighting properly. And here again, SpongeBob rect.x. Okay, so we got that, and now we're just going to search our document for sponge Y to make sure we've cleared out any of those and updated as well. So it's just those other 2 vertical key presses, the W and the S. So we're going to do the same thing where instead of sponge Y, it's SpongeBob rect, but instead of .x, it's just .y. So if you are savvy with your coding editor, there are faster ways to update all 4 of these because they're all exactly the same. But I will assume that you don't know most of those things. So we'll just do them all by hand. Oops, SpongeBob.rect. You do have to be careful when you're typing these out to make sure that you are spelling things exactly the same every time. Okay, so we've gotten rid of all of the sponge X and sponge Y's. So what should happen now when I play this? So we've made this rectangle for SpongeBob. And then we also said, put SpongeBob right at the center of the screen. So we might return to this command here and maybe just change around to see how that the arguments that we're putting into the getRect command worked. But so far it should put SpongeBob right in the middle. And my arrow keys or my direction keys should all be the same. So I'm going to run this. So there's SpongeBob right in the middle. And we can still move around in the exact same way. SpongeBob can still go off the screen because we're not handling any sort of collision there yet, but that's okay. We're just updating our kind of base code here to make it easier to do that stuff later, but that'll be a different lesson. Okay, so let's go back here and let's say, what if we wanted the, let's say we wanted top left. Let's just check the spelling on top left. It is all lowercase. Let's say top left should be screen width divided by 2, screen height divided by 2. This is kind of more similar to what we had before. When I run this, SpongeBob, you can see that its top left coordinate now is right in the center of the screen. So that means SpongeBob and Patrick are actually starting kind of a little bit more to the right and a little bit lower than they should be. So that's one of the things we can do there. Let's see the exact opposite thing happen. Let's look at maybe the bottom right. I think it's all lowercase again. So bottom right, if we make that the halfway point, width and height, then we should see now SpongeBob is starting. The center of the screen is right around here. So that means the rectangle is kind of over here. And it's the bottom right that is now mapped to the center of the screen. So SpongeBob is starting a little bit on the left and a little bit higher than it should be. But we want SpongeBob to start right at the center for this one. So we'll just change that back to center. And now SpongeBob is, again, dead center in the screen. And we didn't have to do any extra math in order to make that happen. Okay, so what we're going to do now, if you feel like you want to take this as an exercise to update do the same thing for the pineapple and the starfish, feel free to go ahead and do that. That's a good exercise to do. Or if you want to wait and just see what my variable names I choose are, it's going to be pineapple rect and starfish rect. Spoiler. But if you want to stick around just to see how I set things up a little bit, then you can pause and try to update things. But that's going to be the rest of this lesson here. So I'll maybe get in my pineapple rect and my starfish rect first. And then we'll go from there. So the pineapple started off the screen, minus 50 on the X, and it was 200 pixels down from the top. So we're just going to try to remember that to put the pineapple in about the same spot because we are about to get rid of pineapple X and Y. So we'll follow the same kind of idea that now we've got pineapple and we'll say underscore rect. We don't have to name it this. I'm just trying to be consistent here. But now we say it's the pineapple variable, which is that image surface, and it's going to be .getRect. And again, now we put in some coordinates here. So if I want the, this was like its top left coordinate. If I didn't want to do any different math here, I could just do this exact same thing. So we'll say top left is equal to minus 50 and 200. That's probably the easiest way since I already did the math there, that now the top left is equal to minus 50 and 200. But if you wanted to do something like, say, top right, this would also be equivalent, where if we just wanted it just off the screen, so we could say that the top right of the image is 0 and 200, and then we don't have to start with that negative value. But these would be the same things. Again, it's just kind of navigating around the rectangle using whichever reference point is the most convenient. I think I'm going to leave it like this just because I think that not having that negative number looks a little bit better. So we will have to search for pineapple X and Y later, but we do need to remove those. Let's do the same thing with the starfish. So we'll say starfish, and we're going to say it's a starfish rectangle. That's going to be equal to starfish, which was the original surface name, dot get rect. And let's look at how we can do this. So X was starting on the screen, it's top left, and starfish Y was 100 pixels down. So for this one, I think it makes the most sense to say that the top left is equal to the same 0 and 100. It's probably the easiest thing to do there. And we're going to keep this star move right true. That's not something we need to get rid of. Okay, so that will make the starting points exactly the same. And we've got our speed variables. We don't need to change anything for that. So I'm going to do the same thing. I'm going to do Control F, or if you didn't want to use the keyboard shortcut, these things are in like find and replace. We're using find here, Control F. So you could do the same thing here and search for example, pineapple X. So we're looking on the hunt here to change all of these pineapple X's to pineapple Y's. So there's a few of them here. So what we're going to do, actually, let's do the find replace all. Let's do, we'll do replace. So we're going to find every time there's a pineapple X. This is just going to do it all at once, and we don't have to quite be so careful each time. So we're going to say everywhere there's a pineapple X, I want to replace it just like I did with the SpongeBob. It's going to be pineapple rect dot X. That's what we want to replace every pineapple X with this. So if we look just to the right here, there's an option to replace this single occurrence. Or if we go just to the right, there's a replace all. That's the one I actually want to do because I don't want any more pineapple X's in here. These should all be pineapple rect.x. So I'm going to hit that. And let's look at, there was a bunch of those ones. You can see that now it says no results when it searches for pineapple X. So they have all been gotten rid of. And everywhere there was a pineapple X, we did get them changed to pineapple rect.x. So I'm going to do the same thing here. I'm just going to go back to this window, look for pineapple Y. So it is highlighting, again, a few of them. There should be more of them, I feel, right? Oh, I guess, no, there's only the one because pineapple, all the movement was horizontal for the starfish and the pineapple. So there weren't any more references to pineapple Y. So this is a bit overkill because there's only the one match, but it's good to be safe. So we want to replace all pineapple Y's with pineapple rect.y. So let's do the same thing, but we'll change it to starfish X. Starfish X. So you can see that's highlighting one here, and it should highlight the ones in the starfish moving left and right. So there's 1, 2, 3, 4, 5, 6, and a total of 7 of them, which we can kind of see here. We're on the highlighting the first one of 7. So we want to replace all 7 with starfish. So just be careful when you spell this out. Starfish rect.x. If you make one typo here, it's going to make that typo go in all 7 places. So starfish X gets replaced with starfish underscore rect.x. And then we're going to go replace all. Now it's showing no more results for starfish X. That's good because that's replacing all of them. And the places where they were, you can see they all got swapped around. So we'll do the same thing with starfish Y. And there's just the only one starfish Y variable. So we just replace that single one there. And now everything should be updated. I'm just going to do a quick search for sponge X. No results. Sponge Y. No results. So those are all replaced. And now we have, we just did the ones for starfish and pineapple. So those should all get fixed. Oh, there is one spot actually that got a little careless with here. Okay, so we did replace all of the pineapple coordinates here. This might still work. I'm just going to try to see if this works. This might not be broken at all. But you can see the difference. I did I do actually want to, I think, get rid of this coordinate. I'm just going to see if it breaks anything. I think it's actually fine. It's just kind of the longer way to write it because we don't really need to give that coordinate anymore. So everything is working exactly the same, which is what we wanted. But it's now structurally in the code a lot more flexible because we'll be able to do things like check when the top of this image is at the top of the screen, and then if it is, don't let it go off. Or if the rectangle for SpongeBob is on top of or overlapping with the rectangle for the starfish, we can register that as like, oh, they've hit each other, and then run some other code. But let's just make this a little bit better here. So rather than this coordinate with starfish rect x and starfish rect y, remember we can just go starfish rect. The same thing like with the SpongeBob. So let's make that change here. Pineapple rect. Okay, so I think that is everything. I'll just close this terminal window so I can see a bit more. Looks pretty good to me. Okay, so if this runs and there's no errors, then that's it for this lesson here. And it looks like we're doing pretty well. So, like I said, we didn't actually have any changes visually, but the code in the background is working quite a bit better. It's going to be easier to do the other things in a game that you might want to do. So, we'll say that's it for this lesson, and see you next time.